All right, now we're moving on into the meat of this chapter. We're going to talk about exponential equations and inequalities. So I want you to be able to use the properties of exponents to solve exponential equations and/or inequalities. Now, what is key here? Key here is knowing your exponents, your powers. If you don't know those, you could be in trouble. So, know your powers. And no, this is not talking about superpowers, so don't even try that. It is talking about your number powers. For example, I should know that 2 to the 0 is 1, 2 to the first is 2, 2 to the squared is 4, 2 to the third is 8. And notice that the negatives are the reverse of that. Because a lot of this is about us being able to go back and forth between those. So, here's how this works. The idea is we want to have the same base, and then we're just basically dropping the bases and setting the exponents equal to each other and solving. Okay, so, for example, simple example, 2 to the x is equal to 8. Okay, 8 is a power of 2 if you go back to the, say, powers that you have here. So instead of saying 8, I want to write this as 2 to the third power. So now I'm saying on the left side, I'm going to work it as 2 to the x equals 2 to the third. Now, what I try to do is always work it down to the lower number, so like the lower base. In other words, it's easier to take 8 down to 2 cubed than it is to try to take 2 up to whatever 8 might be. Okay? So always, like you're always thinking going lower. Alright, so then once the bases are the same, those bases are the big numbers, then you can drop the exponent and say x equals 3, and there you go, you got it solved. Now, let's try one that maybe a little bit more. Okay, same idea, but now notice how I put 8 cubed. Okay, well then that means that I'm going to convert 8 to 2 cubed, but there's still that 3 exponent that's right there. And then what do you do when you have a parentheses between the exponents? You multiply. So now I'm saying 2 to the x power is 2 to the ninth, and so x equals 9. So those are some basic ones. The idea there is trying to, again, get it to the point where you can just say, get them into those same bases. So now let's look at the idea when we try to do more. Here's another example. Okay, so we got 9 to the 2x minus 1 power equals 3 to the 6x power. Now, the idea again is that you want to get it to the lower power. So we want to convert the 9 over to the 3. So 9 is 3 squared. And then you still have that 2x minus 1 power. So now I'm distributing, and then I get, okay, they're both the same, so now I can just say 4x minus 2 is equal to 6x and solve it. And you should know your steps to solve it. As I always like to say, variables to the left, numbers to the right, then you can divide, and there you've got your answer. Okay. So the idea again is to try to convert the numbers and to make sure that they have the same base. Otherwise, that's really what you have to do here. Okay. What happens if they're not the same base? Like, 8 is not a power of 4. There's no way, well, what most of us may think, we can't think of a way to convert 8 to a 4, so we have to go lower for both of them. Well, both 4 and 8 are powers of 2, so I'm going to work them like that. 4 is 2 squared. 8 is 2 cubed. And then I can just go ahead and multiply or distribute, get rid of the exponents. Now I have 2x minus 6 equals 9, and solve from there to get 15 halves. Okay, so the idea again is mainly trying to make sure we convert to the smallest one. Is it any different for an inequality? No, but you know, just kind of keep working at it. Here's another example. When you see a fraction like this, think that the exponent is probably, like the conversion is probably going to go to a negative. 243 is 3 to the 5th power. But since it's 1 over 243, it's negative 5. And then again, now the bases are the same, so I can set the exponents equal to each other, and then just go about solving them however you would normally solve them. So when we see fractions, think that the exponent is going to end up being negative. And like I said, if you have a table that tells you all these powers, it makes it a lot easier. So it's a lot easier, like if you go back to like what I did here with the 2's, it's a lot easier if y'all did something similar to that. Okay, so, whoops, went too far. There we go. So you can kind of see how those work. I gotta stop doing stuff like that. Anyways, alright, so here's another example. Oh no, this is an inequality. There's no more equal sign. I have no idea what to do, sir. Guys, it's the same thing. Calm down. Please, breathe. You'll be fine. Alright, here we go. So 1 over 32 is 2 to the negative 5 power. So notice, again, the fraction became a negative, is expressed through negative exponents. Okay, so now the bases are the same, so I can say x plus 2 is greater than negative 5, and so x is greater than negative 7. Easy peasy, all good. Alright, so here's my last example. And here's another one that looks like it's hard because you can't see which power it is. But 27 and 81, see, this is where the chart would help, are both powers of 3. So I can rewrite the 27 as 3, or I'm sorry, the 1 over 27 as 3 to the negative 3, but that's going to get multiplied to the 2x minus 2. And I can rewrite the 81 as 3 to the 4th, which is going to multiply the x plus 4. And then I could just go about setting the exponents equal to each other, solving, distributing, and then doing, like, say, numbers to the left, I'm sorry, variables to the left, numbers to the right. So you can see my work there as I'm going variables to the left, numbers to the right. But again, these are steps that you should know. This is kind of the point. This is one of the reasons why you were doing, like, these type of solving back, say, in, like, say, middle school or 9th grade with Algebra 1. Now you're taking that same idea and adding it to something else that you should know. Anyways, that's all the examples I have for today, because I want to stick to this one just about solving, and then next time we'll look at some of the word problems and applications. That's it for today. Thank you so much. Y'all take care.